Okay, let's finally set this rectangular and polar coordinate problem to rest. All right, the difference between rectangular coordinates and polar coordinates. When we have rectangular coordinates, we have an x and a y value. This you know. So for example, if we have -3, 5, it sits here. And we know that if it's a negative in our x term, that means they're going to go left or right. A negative is left and a positive is right. And we know that for a 5 in our y term, it's going to be about up and down. So a positive is up and a negative is down. That's the direction that they're supposed to go. When we're talking about polar coordinates, if we have, let's just say, -3, 5 in rectangular coordinates, we could use -3i and 5j as vector coordinates. Or for polar coordinates, we use r, theta, or which would be 5 and 60 degrees, where r is a distance, a definite directed distance, and theta is a number of degrees. And you can write it in either of these two ways. You can do it with the r and the theta, or you can use this funny little line thing here. Please note that polar coordinates use the distance and the angle. So if you ever get confused, if there's an angle, then that will give you a clue, the distance r and theta. Okay, let's keep going. When we talk about polar coordinates, we always measure from this polar axis right here. We're going to always measure up and around like this for positive angles. You'll notice here is our r, and here is our theta. So from up, when we measure up to our r, that is when we are positive. If we measure down in a negative direction, we have a negative angle. And I changed all of these so that you can see what that means. So here we'll have -15, -30. So you know when we measure in a positive direction, 90 is up here. And when we measure in a negative direction, 90 is down here. You have to keep that in mind. Moving along. All right, let's just say we've got 3 polar coordinates here. When we're looking at our polar graph, here is our polar axis, and here is what they call the pole is in the center. So our polar coordinates are 5 and 60 degrees. So here we start at 5, and we follow it around to 60 degrees, and that is where we put our point. If we have 9 and 215 degrees, then we find our 9 here, and then we follow it all the way around to 215 degrees, and that's how we would measure that. Now if we have 3 and -45 degrees, we find our 3, we go in a negative distance to 45 degrees. And that's how we would find that. That's the way the polar coordinates are measured and graphed. Every polar coordinate has a positive and a negative angle. Together they create an entire circle of 360 degrees. So when we look at 5 and 60 degrees, if we measure it here, we see that the rest of the circle here we would say is our negative, which is -300. So when we work with these, we have to know that for this point right here, we have 560 is one of the polar coordinates, and 5 -300 is one of the other polar coordinates. And don't forget, you always start here at the polar axis. Moving up is positive, moving down is negative. Moving on. We have also the r can be opposite. That can be negative. The opposite r coordinate is written as a negative or negative r. So if this is +5 here, down here is -5. And a smart thing to do is always denote your negative as a dashed line so that you can keep track of which one is positive and which one is negative. They are also in a different quadrant, which means that they have different angles. You can't say if this is 60 degrees that down here, you can't just call that -60. That won't work. It's a whole different quadrant, so we're going to have to look at that differently. What we can do is, let's say here is our 560 or our 5, negative 300. When we go on the opposite side, we end up here in our third quadrant. So we are going to start here at our polar axis, and we're going to go all the way around to this R. Whoops. And that is going to be 240 degrees. So we have R, we pass 180, and we go all the way to 240. And here, if we go in a negative direction, we start at our polar axis, and we go down all the way to this point, or this R, and we end up with negative 120. And notice that 240 plus 120, those happen to equal 360 because it is a full circle. So when we talk about our polar coordinates, we've got 2 here for our positive 5. We've got 2 here on the other side for our negative 5. And each one of these has to equal one full circle. So 60 plus 300, 360. 240 plus 120, 360. All right. Now for an example, find the other 2 polar coordinates for those shown. Now, I'm giving you 3, negative 45, and 3, positive 315. So here's our positives. That means we're going to take 3, we're going to go down to negative 45, or we're going to take 3 and we're going to go all the way around to the R, or our what from a triangle would be our hypotenuse, or the radius of the circle. And that would be 315 degrees. So those are given. So the first thing you have to do is you're going to find the negative R first. We're going to go on the opposite side, and we're going to go the exact same distance, and where does that end up? So we know that the first thing we have to write down, since we have 2 for positive 3, the other ones are 2 for negative 3. So that's the first thing you have to do. Now you have to find the angles. And in order to do that, it often helps to draw a triangle. So we've got this triangle here. And you will notice that if I take my first 3 and negative 45 degrees, I can tell that this triangle right here, this theta, if I look at this angle, that's a 45-degree angle. That means on the other side, because they're vertical angles, that's also going to be 45 degrees, which means it's easy to find my first angle here at negative 3, because I would have to start and go all the way around to this R, and that would be 180 minus R. So look at this. I'm sorry, not 180 minus R. 180 minus this 45-degree angle. So to go from here in a positive direction, we're going to say 180, this point right here on the axis, minus the 45 degrees of this angle, and that will give us what's left. To do the other side, there are 2 ways that you can do this. You know it's going to be a full circle. So you can either say 360 minus 35 degrees, or you can start at your polar axis and drag all the way around to the R, to the radius, and you will see that it's 180 plus 45 degrees. So that's how you find those. So our positive angle is 135. Our negative angle is 225. And when we write that, we want to be very careful that we don't forget which is our positive and which is our negative. Going upward and around, which would be counterclockwise, that's positive 135 degrees. The other side of that is the negative 225. So here are the other 2 coordinates. Here's your turn. Find the other 3 polar coordinates for 7, or negative 7 and 87 degrees. You can pause now and try it. Okay, here are the answers. To find the others, we have negative 7 and 87. So first, find the negative half of the 87 degrees. So we're just going to say, oh, that's easy. 360 minus 87 degrees is going to be the other half. So now I have negative 7, 87 degrees, and negative 7, negative 273. Now I'm going to find the opposite R, which happens to be the positive side. So in order to do that, we're going to first find the angle. So we go up to 87 degrees, and we say, all right, we're at -7, 87 degrees. If this is negative, it's the dashed line. The opposite side is positive, so I'm going to have to go all the way around, which is going to be 180 plus this 87 degrees, and that will give me the whole thing. Now, to find the negative side of this, you're going to have to go from the polar axis in a downward direction, so you're going to go clockwise, and we're going to take 180 and we're going to subtract this 87 degrees to give us this point right here. So we've got 267 degrees and 793 degrees for the last two measurements. I hope that helped. If not, go through it again. If not, after that, then come and see me in class.